everyone, in this course we are going to learn what is Pemdas rule with the help of a few examples. We will get to know why is it important for us to learn this rule in order to solve the algebraic equations. We will also clear out the confusion that either Pemdas different from Bodmas or is it the same rule just with a different acronym. And lastly, I will provide you with some practice exercises to help you get better grip on the new algebra knowledge that you got from this course. Are you excited? I'm so excited. So without any further ado, let's dive right in. First of all, let's see why order of operations matters so much in solving any algebraic expression correctly. Let me explain this with an example. Let's say we give the same algebraic expression to two different people to solve and give us the answer. The names of these two people would be, let's say, Mr. A and Mr. B. And the algebraic equation that is given to them is 2 plus 4 into 6. Also, keep in mind that they are unfamiliar with the concept of Pemdas. They are totally oblivious of the notion of order of operations. So they are going to perform the operations the way they want. Alright, so the first person, Mr. A, loves to do addition. He is just so good at it. So he added 2 and 4 and got the answer 6. Then, to finish off solving the expression, he multiplied the answer of the addition, which is 6, to the other 6 in the expression and got 6 sixes are 36. On the other hand, Mr. B, who thinks he is smarter than Mr. A, started solving the expression with doing the multiplication first. So he first multiplied 4 and 6, which gave him 24. Then to finish off solving the expression, he added 2 to his current answer and that gave him a total of 26, which is completely different from the answer that Mr. A got, which is 36. And we have no way to figure out which answer is the correct answer. Now, this inability to get to the same answer after solving the same problem by different people would produce a hazard in the mathematical world. The mathematical techniques that are known for their problem-solving utility would produce even more problems than solutions, because there will be no precise answer to a single problem. That's why the mathematicians established the convention Pemdas or order of operations with the passage of time at least as far back as 1500s with the help of their own observation and practice to remove ambiguity and confusion. Now let's see what this rule really is and what does this acronym Pemdas stands for. So the letter P stands for parenthesis, E for exponents, M for multiplication, D for division, A for addition, and S for, yes, you guessed that right, subtraction. So Pemdas is basically a rule of precedence of mathematical operations, also known as order of operations. So when we have two or more than two operations in a single expression, the rule Pemdas guides us which operation needs to be solved first. We solve the mathematical operations in a given expression according to the order of the letters in the acronym Pemdas. So the operations that are being grouped or inside the parenthesis needs to be solved first, where parentheses can either be round brackets, curly brackets, or square brackets. Next operation that needs to be solved according to the order of operations is exponent. After that, we got multiplication and division. Now, there is no hard and fast rule for which one of the two should be solved first, but mathematicians didn't leave you alone here. To get the correct answer of an algebraic expression, it is recommended to perform the operations from left to right if both the multiplication and division happen to appear in the same expression. Lastly, we have addition and subtraction in the Pemdas rule. Similar to the multiplication and division, it is not necessary to solve the operation of addition before subtraction. Both of these operations are ranked equally. But it is recommended to perform these operations from left to right in order to get the accurate answer. Now, let's put all the theory aside and start solving some examples. Shall we? We will start with something relatively easy and then we will work our way to some complex examples. Example number 1. Let's take this expression 4 into 8 plus 3. Now, if we didn't know about Pemdas rule, we would be tempted to do the addition operation first, because that is the first operation we were taught in elementary school. But since we know the correct method of solving any algebraic equation now, we will solve the multiplication operation first, as the letter M, which represents multiplication, comes before the letter A, which represents addition in the acronym Pemdas. We will keep the acronym Pemdas on the top of the screen for reference. So 4 multiplied by 8 gives us 32. Adding 3 makes it 35, which is the correct answer. Well, that was easy, right? Now, if we change the same expression a little bit and put brackets or parentheses around 8 plus 3, which operation would you solve first? Multiplication? Because multiplication comes before addition in Pemdas? Or what? Yes, the parentheses. I just tried to confuse you there, but you really knocked that out. Well done. By solving the operation inside the parenthesis first, which is addition, gives us 8 plus 3 equals 11. Then by multiplying it with 4 gives us 44, which is the correct answer. Now you can easily see the difference in the answer of the same expression by adding parentheses. Moving on to another example, check out this expression. 2 plus parenthesis open 5 into 3 square parenthesis closed. This got exponential in there too. Now, following the Pemdas rule, we are just going to target what's inside the parenthesis first, which is 5 times 3 square. Next, we need to solve exponent before multiplication, because exponent has greater precedence than multiplication when it comes to order of operations. So 3 squared equals 3 times 3, which gives us the answer 9. 1 down, 2 to go. Next, we solve the operation of multiplication because it is next in the sequence of order of operation. So by multiplying 5 with 9, we got 45. And now we are done with the parentheses. So basically what we do is we see parentheses in an expression, we neglect everything else and start solving what's inside the parentheses according to the order of the operation. Lastly, to finish solving the expression, we simplify the last operation that's left, which is addition, and get the total of 47, which is the correct answer. On to the next example. Consider solving this expression, 50 divided by 2 into 5. We will solve it using Pemdas to get the correct answer. Now, looking at the acronym Pemdas, we can see M comes before D, which means multiplication needs to be solved before division, right? So let's try that. So 2 into 5 is 10. Then we divide 50 by 10 and that gives us an answer of 5, which is the wrong answer to this expression. You may ask why? Well, remember when we talked about order of operations, multiplication and division? Which has higher precedence over which? We discussed that this is not a hard and fast rule that multiplication has to be solved before division, and it is recommended to solve the algebraic expression from left to right when multiplication and division happen to appear in the same expression, as it did in our example 50 divided by 2 into 5. Now let's solve this one more time, but this time the right way. Considering the expression 50 divided by 2 into 5 again, and this time we would perform the division first. So 50 divided by 2 is 25 and 25 multiplied by 5 is 125. See, the answer is different now. That is the reason why it is so important to follow the order of operations to get the right answer. But what if division followed multiplication in the example which is under consideration? Like this, 50 divided by 2 into 5 divided by 3. What we would do now? Simple. We would follow the rule of solving the algebraic expression from left to right. So as we have seen before, 50 by 2 is 25 multiplied by 5 is 125. Now we solve the last division operation in the expression by dividing 125 by 3, which eventually gives us the answer 41.67, which is a decimal number. That example was a good practice for left to right operations calculation. Well, there is also a top to bottom approach, which is used for solving the series of exponentials. For example, we need to solve 2 raised to the power 4 raised to the power 3. Which power needs to be solved first? Now, here we will apply the top to bottom approach by solving the power of the top first, which is 4 raised to the power 3, which is 4 cubed, and it means 4 times 4 times 4 equals 64. Now we are able to solve the base 2 raised to the power 64, which will give us a huge answer. This, because the number 2 is used as a factor 64 times. Alright, enough of these easy peasy examples. Now let's look at a more complex example of order of operations. Let's solve the quadratic formula for a equals to 3, b equals to 4 and c equals to negative 4. For those of you who aren't familiar with quadratic formula, well, quadratic formula is used to calculate the solution for any equation where the power of the unknown variable is 2, which in our case, the unknown variable is x. But you don't have to worry about its definition, as we are just going to do the basic algebra by replacing the values of a, b and c to 3, 4 and negative 4 respectively. So let's start solving the quadratic equation for these values. In this equation we have a variety of mathematical operations. So which one to solve first? Thank God we have Pemdas rule under our belts to solve this problem correctly. We will start by solving the exponent 1 by 2 or square root first, because there's no parenthesis in the expression and exponent comes next. So in order to solve the exponent, we first have to solve the expression 4 squared minus 4 times 3 into negative 4, which is itself another algebraic expression. So we are able to apply Pemdas rule on it as well. We will start by solving the exponent again, because this is at the highest rank in operations priority list after parenthesis, as I explained a number of times in this course. So 4 squared equals 4 times 4, which is 16. Next we have subtraction and multiplication left in the expression that needs to be calculated. Well, we will solve the multiplication before calculating the difference, since multiplication comes way before subtraction in the operations priority list. So 4 times 3 into negative 4 is equal to negative 48. Now what we have to solve is 16 minus negative 48. Since minus and minus equals plus, so 16 plus 48 gives 64. Woof! We have finally solved the expression inside exponential, and we are ready to solve the exponential now, which is square root of 64. So the square root of 64 means 64 exponential 1 by 2, which is equal to plus minus 8. Yeah, the square root has two solutions, a positive one and a negative one. Now the expression we need to solve is negative 4 plus minus 8 whole divided by 2 into 3. Here we need to solve both addition and subtraction operations in the same expression, which is not possible. So we will split the expression into two simpler ones and we will solve both of them one by one. So the first one is x is equal to negative 4 plus 8 divided by 2 into 3. And the second one would be x is equal to negative 4 negative 8 divided by 2 into 3. And we will solve both of them one by one. Taking first expression first. Now, according to Pemdas rule, we need to solve multiplication and division operations before addition and subtraction. And for solving multiplication and division, we need to go from left to right. Since it is a fraction, we need to solve the numerator and denominator one by one in order to solve the whole fraction correctly, because a horizontal fractional line also acts as a symbol for grouping. So negative 4 plus 8 is equal to 4 and 2 into 3 is equal to 6, which gives us x is equal to 4 by 6, which on simplifying gives 2 by 3. If we simplify it more, it will give us a decimal answer. So we are gonna leave it like that. On to the second expression. We will do the same thing as we did for the first expression. After solving negative 4, negative 8 and 2 into 3, we have minus 12 by 6, which gives us the second value of x, an integer negative 2. Alright. I think we have done enough examples together that the order of operations must have gotten clear in your minds. But don't worry, we have some more practice exercises as well at the end of this course for you to solve and get a better grip on the order of operations. Now let's address the elephant in the room, how to remember the order of operations. A lot of students find it difficult to remember the correct order of operations when there are a plenty of operations to solve in a given expression. Well, this is the part where we take help from mnemonics. The first idea would be to remember it by its acronym Pemdas, which stands for parenthesis, exponent, multiplication, division, addition and subtraction. But there are other better ways, even funnier ways to remember the order of operations. For example, to remember it using a phrase. You will see a lot of them going around, but the most popular one is, please excuse my dear Aunt Sally. If you have an aunt named Sally, you will remember this, but if you don't worry, you can come up with your own phrase to remember this concept forever. It will be fun. Alright, we are almost done with this course, but before signing off and leaving you with a lot of practice exercises, I want to address the confusion about Pemdas and Bodmas. Are they different rules for the order of operations or the same rule, just different acronyms? Well, the later one is correct. Pemdas and Bodmas are actually the same rule, just with different acronyms. Pemdas stands for parenthesis, exponent, multiplication, division, addition and subtraction, whereas Bodmas stands for B for brackets, O for off, D for division, M for multiplication, A for addition and S for subtraction. You might be confused, what does this off means here? Well, off here means power off or order off. Off generally means to multiply, like 1 by 2 of 81 is basically the square root of 81, which is 9 or plus minus 9. Or 3 by 2 of 4 is basically cube of 4, which is 4 into 4 into 4 equals 64, and then square root of 64, which is plus minus 8. So actually off in Bodmas represents the same exact thing as E represents in Pemdas, which is exponent. And same goes for brackets. In Bodmas, the brackets too represent round, curly and square, all three kinds of grouping, similar to the parentheses in Pemdas. So the main idea that both of these acronyms try to get across is that the multiplication and division needs to be calculated before addition and subtraction. Now you must be wondering, then why do we have the same rule with different acronyms? So the thing is, different acronyms for the order of operations are being used in different countries. Like Pemdas is popular in the US, while Bodmas is common in UK and South Asian countries. So it is basically just the preference of the natives, but all these conventions are actually the same as we have discussed earlier. Alright, it's time to wrap up the entire course with some helpful yet brain teasing practice exercises. And don't worry if you get stuck, we have attached the solutions to the problems for you as well. But go for solutions only when you get stuck. Also, no peeking. That's it for our course, and thank you so much for watching. Bye!